Welcome to YouTube channel of ASSMS IIT. I am Archana Ubale, Department of E&TC, ASSMS IIT Pune. I am going to explain you the type of the stepper motor, that is variable reluctance stepper motor. Variable reluctance stepper motor, this is the very basic type of the stepper motor, and this can be able to explain you the principle of operation of the stepper motor. So stepper motor, the name itself indicates that this stepper motor moves in a step. And here this is the one of the type of the stepper motor, that is variable reluctance stepper motor. In this stepper motor, the stator switch is usually wound for 3 phases. So here in this diagram you can able to see the stators of this stepper motor, that is wound by the 3 phases. These having the 6 silent poles, and the construction of this stator, that is laminated and assembled in a single stack. The number of poles of stator and rotor that are different. So here in this diagram you can able to see the stator poles are 6 and rotor poles are 4. Variable reluctance type of the stepper motor, this can be able to rotate in both sides, is bidirectional rotation as well as the self-starting. So here we are going to see the operation of this variable reluctance type of the stepper motor. So according with the reluctance, where is the reluctance, the rotor adjusts itself with respect to the low reluctance position. When any one phase of this stator that get excited, it produces the magnetic field along the axis of the pole and phase around which is excited. Then the rotor moves in such a direction to achieve the minimum reluctance position. Such a position means position where axis of magnetic field of stator matches with the axis passing through any two poles of the rotor. So here let us we see the operation of the variable reluctance type of the stator motor by exciting the each phase. So when phase 1, phase A dash, that is excited by closing the switch which is connected to this phase. So when this A dash phase get excited, the stator magnetic axis that is present or that get formed along the poles formed due to the A dash phases in a vertical direction. So here you can able to see in the diagram, this form the magnetic poles. So this is the N pole and this is the south pole. Then rotor adjusts itself in a minimum reluctance position. So here already rotor in that position. So this is the minimum rotor reluctance position. Then after that, when first phase get excited, this is the position of the rotor. Then the switch which is close to the A dash phase that get open, and now the switch C dash get closed. So when C dash get closed, this phase get energized and that forms the poles, and previous A dash phase get de-energized. So when this get energized, the rotor pole that adjusts itself to the minimum reluctance path. So movement of the rotor, that is in the step. So rotor moves at a 30 degree. So you can see able to see over here in the previous A dash position is excited, the rotor is at this position, and when C dash get excited, rotor position get changed and that gets shifted in the 30 degree. In third condition, when C dash phase get de-energized or switch get open, and after that B dash switch get closed, and these two get energized, B dash get energized, so that forms the poles, and again rotor adjusts itself its minimum reluctance path. So position of the rotor is this. So rotor gets shifted over here, and this shifting of the rotor, that is the 30 degree. So total shifting in this 6 position pole, that will be the 30 degree, 60 degree, sorry. Thank you.